So hello guys, welcome back to a new video, and as discussed in the previous video, today we will talk about space and time complexity. Now when I say that space and time complexity, you should know that we will talk about the only basics which we are required to learn before starting the sorting. Okay, so I think that should be clear to you till now. Secondly, I would like to inform you that this video will not be included in the playlist which I previously informed you also, and I think all the information part is done, so we should start now. Now let me ask you a question before starting this space and time complexity. Have you ever experienced any time lag in an app, and then you have wondered why is this app running so slow, or you have scandalized, okay, in the worst case, uh, you've scandalized why is this app not working in time, or why is this app taking too much space on my phone or whichever device you are using. And this is a case which happens more often in case of games. Okay, when we talk about games, they require a lot of space, and when we experience a time lag in a game, then our temper is leveled up. Okay, I hope that you all can relate by this. And uh, to minimize that, we use algorithms and data structures which use the least time and space complexity. Okay, sorry, I said data structure. Mainly, we talk about algorithms. Okay, we talk about the algorithms which uses the least time complexity and space complexity. And why I'm saying the words time complexity and space complexity again and again, I'm saying it again and again because these two words are the parameters which determine if the app or the game or anything software, or you know what I'm trying to say, okay, takes more space, less space, more time, less time, or we can say favorable space and time. So starting with time complexity. Now, if we talk about time complexity, then we take three cases. Okay. Now, what are these three cases? Let me write it here. First is the best case. Okay. This is the best case scenario. Wait a minute. Yes. Case. Sorry, my writing is a little bit, we can say, not appealing. Then we have average case. Okay. The average case looks a little bit average. And then we have the worst case. And as we know that we should hope for the best but prepare for the worst, this indicates that we have to focus on this worst case scenario. Okay, worst case scenario. Now why I'm saying the worst case scenario, because we have to be prepared for the worst case in any app. If there is an exception, okay, when we talk about an exception, it results in the ambiguity at the end of an user. Okay, uh, is the word ambiguity correct? Actually, I have to go through my vocab again, but you know what I'm trying to say. It causes problem. Okay, it is catastrophic. Secondly, the thing is that we have to use the worst case in this case. Case. It's a sort of funny, but yeah, we have to use the worst case so we can find out what will be the output in the worst case scenario. Okay, and we have to maintain that it should not hamper, sorry, it should not vary with our device's configuration. Okay, if an app runs in our laptop in a good way, then it should also match the expectation of a mobile user. Okay, here we are talking about space and time complexity both. Okay, so how many times I say okay, again said it, leave it. So we denote best case, by this symbol, which I know you might be thinking is ohm, which is the unit of resistance, I guess, if you are from physics or science background. But here we call it omega. Okay, we will call it omega here. So if we are writing here 1 in parenthesis, we will write omega of 1. Why we should only consider 1? We should consider 2. The average case is written like this, theta, and then we can write here like n plus 2 upon 2, like this. Now this can vary. We will not talk about this now. Oh, I crossed it. But it doesn't matter, so leave it. Then we have the main part which we have to study. Okay, ON. We write it like this, and this is the part which we have to study. Okay, so we'll talk about this in our time complexity part. So let's remove this whole part. Okay, this piece. Oh, let's use an eraser here. Again, using a brush, pencil, whatever it is. Okay, marker. Okay. Now, if we talk about space, sorry, we were talking about time complexity right now. We were talking about the ON. Okay, now here it can be n square, or it can be like O of n cube, or whatever it is. It can be any expression, you can say. Okay, and I just realized that the thickness is too less. Okay, let's leave that. I combined that and it. Now I'll just leave that. Here we will go here to take the example. Okay, this was the project of our previous video, arrayoperations.java. I opened it because I wanted to explain you how this works. Okay, so let's move to the window again. Now, when I talk about time complexity, what do I actually mean? When I talk about time complexity, I mean total number of operations. Okay, total number of operations. Now, if I say that okay, so I took a large pause. That is justifiable because I wanted to drink water but I couldn't. Okay, leave that. Here we have for, and again we have for. Now what I am trying to say is, here we can calculate the time complexity by the number of operations carried out. Now how do we calculate the number of operations? Now let's see. Here we have for int I equals to 0 and I less than arr dot length. Okay, let's remove this and this also. Wait a minute. Yeah, okay, let's keep this, don't worry. Here we have this and this. Now if we say that in this for loop, i's value of I is going from 0 to arr dot length, okay, less than length, arr dot length, so it means that it will go like 0 comma 1 comma 2. Okay, the value of I will be 0, then 1, then 2. Now in this 0 comma 1 comma 2, when we talk about 0, taking a separate case, the value of j will be here 0 comma 1. Am I right here? Wait a minute. Yeah, I'm right. 0 comma 1. So here we have 0 and then we have 1. So in this case, if we see that here we have the number of what I'm saying, number of values of I are 3. Okay, 0, 1 and 2. Here the number of values of j are 2. Okay, 3 into 2. Now if I say that in the first round the number of operations were m, and in the second round the number of operations were n, so according to simple mathematics we can say that the operation, or we can say the number of operations, was m into n. Now that was the case if only one operation was carried out in here, but here we have two operations. So how does it affect our equation? Simply we will multiply 2, which will not cause any we can say much difference because it is a constant. So we will write it like this, 2mn. Okay, because we are repeatedly performing two operations, so we have to multiply 2 here. Okay, now I just realized I again said okay, so I won't be saying okay for some time. Is it okay? I again said it. Damn. Okay. Let's leave that. Moving forward. Yeah. So I think I have explained you this. Now, if we talk about any other operation, uh, what do I mean here? If I say that I have this and then I apply one more for loop. Okay, this was the story of for loop only. We were not considering this, and yeah, we had to consider this. Okay, because this was out of for loop, but we had to consider this. So it was like here we had here we had 1m and then into this 2n, so it was again 2mn, so it didn't make a difference, although we had to consider that. I'm sorry because I did not, because I forgot. Wow, it also rhymes. Anyways, for int k equals to 0 and k less than 4 and k plus plus, unary increment operator, system dot out dot println time. Okay, now here's the twist. Oh, I bookmarked it. That wasn't the twist I was expecting. Okay, so I ran it here. Now as you can see, this is one process and this is second. Now when we talk about this, then we will be adding, not multiplying. Okay, in this case we were multiplying the number of operations carried here and here, because in this individual value of I there were multiple functions carried out. Okay, sorry, operations. There were multiple operations carried out because in this I, in the single value of I here, the multiple value of j are playing a role. Okay, I think that I've made my point clear. And if I want to calculate the time complexity of this as a whole, so what will I do? Okay, so the number of operations here are, we have to count 0, 1, 2, 3. Okay, again we have 4. So in this case we will simply add it. Okay, here we will write plus 4. This is an easy expression. I was about to say operator. Okay, so let's leave that. Now I think this is clear, and that's how we calculate the time complexity. And I know that you know that we have to maintain a minimum time complexity. Okay, let's keep this much part. No. Let's remove it because we need some space, okay? And we again have to remove this. What am I doing? 10 pixels. Again, I am erasing it. Marker. Yeah, let's keep this thick only. Okay. So now, as we have completed time complexity, now it's time to move to space complexity. Now, when we talk about space complexity, what does come in your mind? Something related to space? Yep, you are right. Anything more? Yeah. What will I do if you explain all the things? Let me explain this. Okay, when we talk about space complexity, we have to maintain a minimum space for our app, software, whichever thing we are using, or basically we say code. We have to maintain a minimum space of our algorithm, or we can say our algorithm or our code requires minimum space. And when I say that, what do I mean? When I say that, I mean that, what do I mean? Okay, so I have a formula here, which is space complexity equals to auxiliary space plus space used for input values. Okay, this is the formula of space complexity. Now we know that we have to maintain this, we can say, as minimum as possible. Now to do this, we have two criteria on which this is based. Space complexity is based on auxiliary space plus space used for input values. Okay, so here is auxiliary space. Now first question which arises in our minds is, what is auxiliary space? Now here is the definition of auxiliary space, which is given by Geeks for Geeks. Auxiliary space is the extra space or temporary space used by an algorithm. Okay, so as it says that auxiliary space is the extra space or temporary space used by an algorithm, which means that it is constant. Okay, if I say it is constant, what do I mean? Do I really mean it? Okay, so here is this. Here we have what is an example of auxiliary space, but we do not need to open this. What is the constant auxiliary space? Constant space is the one that is fixed for the algorithm, for that algorithm, generally equals to space used by input and local variables. Auxiliary space is the extra temporary space used by an algorithm. And sorry, I just said that it is constant, but let's not keep that in mind. It may change in some situations, or let us see it by our own. Okay, let's type, is auxiliary space constant? Okay, so it is like a quiz. What do you say? Comment down. It means they, oh, wait a minute. It means that the amount of extra memory or auxiliary space used by the algorithm remain constant regardless of the size of the input. In other words, no matter how large the input array is, insertion sort will use the same amount of additional memory to perform the sorting operation. Okay, so now it is clear that auxiliary space is constant. And why is it so? The auxiliary space is constant because it is assigned by the computer, we can say. Okay, we don't have to do anything in it. The thing which we have to do something with is our input values, space used for input values. Because if we say that we have inputted an array, or we say that we have inputted an string, the size matters. Okay, and the size space is dependent on our size of the string or any other data type which we are talking about here. Now, if we say that we maintain a constant space in here, then we can achieve a good amount of space complexity. And by a good amount, I don't mean large, but a decent amount which will give us an optimum performance. Now, I think I've made my point clear here also. And as this was a basic video, it did not cover much, we can say, advanced concepts, but I think it gave you an overall idea of what does space and time complexity actually mean. And that's what I want for the next videos. Okay, and again said okay. Yeah, bye bye. And also I forgot to say bye bye, and I switched the tabs. Okay, sorry for that.